Hello and welcome to my YouTube channel. If you love math and want to learn in a fun and easy way, you are in the right place. We make learning fun by solving tricky math problems and sharing cool math tricks. Subscribe now and join the journey. For rule number 1, let's consider any arbitrary constant c. We can say that the derivative of this constant c with respect to x, that is denoted by dc over dx, is 0. So let's focus on some examples. For the first example, we consider 30 as the function. So we can compute the derivative of this function with respect to x. So we say it is 0. For the second example, e to the power 10 is chosen to compute the derivative with respect to t. Again, e to the power 10 is a constant, so the derivative is 0. So let's move on to the next example. Cosine pi over 4 is the function, and we are going to compute the derivative with respect to z. Again, you can see that cosine pi over 4 is a constant, so the derivative has to be 0. For the last example, we want to compute the derivative of natural log of 100 with respect to z. The derivative again is 0. This is called the power rule. Our goal is to compute the derivative of x to the power n with respect to x. Now remember, n is any real number. So we can write down the derivative of x to the power n as n times x to the power n minus 1. So we subtract 1 from the original exponent. That's how we got n minus 1. This is called the power rule. I am going to discuss several examples under this rule. For the first example, let's compute the derivative of x to the power 3 with respect to x. Now the original exponent is 3, so we can write down the derivative as 3 times x to the power 3 minus 1. That becomes 2. So the final answer is 3x squared. For the second example, I am going to compute the derivative of x with respect to x. Now remember, we can write down the function x as x to the power 1. So if we apply the second our power rule, we can write this as 1 times x to the power 1 minus 1. Remember, x to the power 0 is always 1. So then we can write down the final answer as 1 times 1, it gives 1. For the third function, I have chosen t to the power 1/2 as my function. So my goal is to compute the derivative of t to the power 1 half with respect to t. Now in this case the power is 1 half. I can write down the derivative as 1 half times t to the power 1 half minus 1. Now I have to simplify this exponent, so I'm going to do it separately. 1 half minus 1, and we have to make the common denominator. So I'm going to multiply the numerator and the denominator of 1 by 2. Then we get 1 half minus 2 over 2. That gives negative 1 half. So the final answer is 1 half times t to the power negative 1 half. Now let's move on to the next example. I'm going to compute the derivative of square root of x with respect to x. Now remember, we can write the square root of x as x to the power 1 half. So I want to use the power rule. Again, this is the same as the third example. So I will write it down, the derivative directly, which is 1 half times x to the power 1 half minus 1. Again, if you simplify 1 half minus 1, we get negative 1 half. So the final answer is 1 half times x to the power negative 1 half. This is the final answer. So let's move on to the next example, which is the fifth example. So I'm going to compute the derivative of the fifth root of x with respect to x. So we use the following notation to represent the fifth root of x. Now let's write down this notation. The nth root of x we can write as x to the power 1 over n. So if you follow this notation, we can write down the derivative of fifth root as d over dx. The bracket, inside the bracket we can write x to the power 1 over 5. Then apply the power rule. The derivative becomes 1 over 5 times x to the power 1 over 5 minus 1. Again, we have to use common denominator to simplify this further. 1 over 5 minus 1. Again, multiply the numerator and the denominator of 1 by 5. Then we get 1 over 5 minus 5 over 5, which becomes negative 4 over 5. The final answer is 1 over 5 times x to the power negative 4 over 5. Now let's consider the sixth example. I want to compute the derivative of the fourth root of x cubed. That is, this is how we represent that function. So in general, we can write down the nth root of x to the power m as x to the power m over n. So if we follow this notation, we can write down the derivative of the fourth root of x cubed as d over dx. Inside the bracket, we can write x to the power 3 over 4. Then apply the power rule. We get 3 over 4 times x to the power 3 over 4 minus 1. Again, we have to make the common denominator to simplify this further, and let's do it separately. So 3 over 4 minus 1, and I'm going to multiply the numerator and the denominator of this 1 by 4. Then we get 3 over 4 minus 4 over 4. If you subtract, we get negative 1 over 4. Then we can write down the final answer as 3 over 4 times x to the power negative 1 over 4. In this case, we cannot apply the power rule directly. In order to apply the power rule, the function has to be in the numerator, not in the denominator. So I'm going to write down this not 1 over x to the power m, we can write as x to the power negative m. When you bring the function to the numerator, you have to switch the sign of the exponent. So if we apply this rule, we can write down d over dx inside the bracket x to the power negative 3. Now we can apply the power rule. So we get negative 3 times x to the power negative 3 minus 1, which becomes negative 4. The answer is negative 3 times x to the power negative 4. For this example, I'm going to use 1 over square root of x as the function, and my goal is to compute the derivative of this function. Remember that we can write square root of x as x to the power 1 half. If you follow this, we get 1 over square root of x as 1 over x to the power 1 half. In order to apply the power rule, we have to bring the function to the numerator. When you bring it to the numerator, you have to switch the sign of the exponent. Then we get x to the power negative 1 half. And the derivative, we can apply the power rule. Then we get negative 1 half times x to the power negative 1 half minus 1. Again, use the common denominator method to simplify the exponent. Then you get negative 3 halves. The derivative is negative 1 half times x to the power negative 3 halves. Let's move on to the next example. I'm going to compute the derivative of 1 over the third root of x to the power 4. So again, if you remember the previous example, we can write down the third root of x to the power 4 as x to the power 4 over 3. Then we get 1 over the third root of x to the power 4 as 1 over x to the power 4 over 3, that is the exponent. Again, for the power rule, we have to bring the function to the numerator. Then we get x to the power negative 4 over 3, that's the function. Then apply the power rule, we get negative 4 over 3 times x to the power negative 4 over 3 minus 1. So you have to make the common denominator to simplify again the exponent. So negative 4 over 3 minus 1. Again, multiply the numerator and the denominator of 1 by 3. Then you get negative 4 over 3 minus 3 over 3, that becomes negative 7 over 3. So the final answer is negative 4 over 3 times x to the power negative 7 over 3. In this example, we want to compute the derivative of 1 over x with respect to x. If you remember from one of the previous examples, we know x we can write as x to the power 1. So then if you bring x to the numerator, you get x to the power negative 1 after switching the sign. Then we can apply the power rule, so the derivative becomes negative 1 times x to the power negative 1 minus 1. Then we get negative x to the power negative 2. For the next derivative rule, we want to compute the derivative of natural log of x. So in this case, I use the absolute value of x because x can be any real number, can be negative or positive. That's why we have to use the absolute value. The derivative of natural log of x we can write as 1 over x. That's the next rule. As the next derivative rule, we are going to talk about the derivative of the exponential function. So in this case, we consider any real number x. The derivative of e to the power x we can write as the same ex. That's the derivative. The next derivative rule is called the scalar multiplication rule. In this case, we consider a constant c as well as a function of x, which is denoted by f of x. Our goal is to compute the derivative of the product between c and the function f of x. So the derivative of c times f of x can be done by bringing the constant c outside and then take the derivative of f of x itself with respect to x. The next derivative rule is called the linear property. For this case, we have to consider two constants. So let's denote this by k and c, as well as we have to pick two functions of x. The first function is denoted by f of x, and the second function is denoted by g of x. Now what we are going to do is pick a linear combination of f and g, which is constant k times f of x plus the constant c times g of x. What we are going to do is compute the derivative of this linear combination with respect to the variable x. It is same as first we write down the constant k times the derivative of f of x with respect to x plus the constant c times the derivative of g with respect to x. In order to get this final answer, what we did was applied the previous rule twice. That's how we get the linear property.